All right, we're back with the second piece of section 3 or section 1 of chapter 3, graph linear equations. By first finding x and y intercepts, you have the ordered pairs of 2 points through which the graph of the linear equation passes. That information can be used to graph the line because, remember, I don't know if you know this or not, but 2 points determine a line. So if you know 2 points and you know it's going to be a line, you put those 2 points and connect them with a straight line, and you can graph it. So let's graph 2x plus 4y equals 16 using the x and y intercepts. So here's something, remember we talked about this. The x-intercept is the point at which the y value is 0. All x-intercepts have a y value of 0. So what we can do is substitute 0 in for y and solve the equation for x. So substitute it in, you get 2x equals 16, divide by 2, you get x equals 8. So that means the x-intercept is 8, because that's the x value when y is 0. So that's the point 8, 0. So we could plot that point right here. Okay. Similarly, we start over again with the original equation and let x equal 0. We substitute that in, and you get 4y equals 16. So you have y equals 4. And that means the y-intercept is 4, and this means the graph intersects the y-axis at the point 0, 4, which is right here. Okay, now we have 2 points, and we can plot them as we just did and draw a line through them. So put your line like that, and then we could put some arrows on it. And that's our line. The arrows simply indicate that it keeps going. Now, I apologize I didn't get it on there exactly right at 8. It's kind of hard to draw with an iPad and a stylus. Can't really put a ruler on it. So, all right. Okay, so here's one for you to try. No, we're not there yet. Sorry about that. Note that the graph in example 4 has both an x and y intercept. And we talked about this previously in the last video. Some lines have an x-intercept and no y-intercept, or vice versa. The graph of y equals b. So if you just have no x value and you have y equals a number, we'll call it b, that's always going to be a horizontal line going through the y-intercept of whatever b is. If you have x equals a, that's going to, x equals some number, that's going to be a vertical line going through the x-intercept of whatever a is. Okay? All right. So every ordered pair that makes an equation true represents a point on the graph. So the graph of an equation represents all of its solutions. Any ordered pair that does not make the equation true represents a point that is not on the line. So let's graph each equation by using x and y intercepts. Go ahead and pause the video and hit play when you're ready. Okay, we're back. So the first one, we're going to get the x-intercept. So we're going to replace 0 or y with 0. So you have negative x equals 3. So remember, that's understood to be a negative 1. So divide both sides by negative 1, and you get x equals negative 3, which is the point negative 3, 0. So that's right here. The y-intercept, you take the equation and substitute 0 in for x. So you have 2y equals 3. Divide both sides by 2. So you have y equals 3/2 or 1.5. So that's the point 0, 1.5. So we put that right about there. Okay, now you have your 2 points. Draw your line. Okay, it's really that straightforward. Okay, now this one, I will say that the equation is not in standard form. It's not ax plus by equals c. So what we could do is first add x to both sides to get it in standard form. X plus y equals negative 5. Now to get the x-intercept, substitute 0 for y. And you get x equals negative 5. So that's the point negative 5, 0 right there. And the y-intercept, substitute 0 for x. You get y equals -5, which is the point 0, -5, which would be right here. You got your 2 points using the intercepts. Draw them, connect them with a straight line. Put arrows on the end, and you're good to go. Pretty cool, huh? All right. So this one, we're going to graph by making a table. So graph y equals 1/3 x plus 2. The domain is all real numbers. That means you can use any number you want. So we're going to select values from the domain and make a table. When the coefficient of x is a fraction, select a number from the domain that is a multiple of the denominator. The reason is because if you, in this case, if we select multiples of 3, it's really easy to reduce, and you get a nice integer when you multiply 1/3 by a multiple of 3. So like 1/3 times 3, 1/3 times 6, 1/3 times 9, 1/3 times 300. All of those work out to a nice number, which are easy to graph. So we're going to create a table of ordered pairs. So if I pick -3, the reason this is kind of easier in a sense is because it's already solved for y. So when I substitute -3 in, I just simplify the right-hand side and I get the value of y. So -3, plug it in, times 1/3 is -1, plus 2 is 1, so that's the point. 0 is also a multiple of 3, and it's really easy to multiply by 0, so you get 2. We're going to plug in 3 as well, and you get 3. And plug in 6. Okay, so here's our graph. We're going to plot the points. -3, 1 would be right about there. 0, 2 would be right about there. 3, 3 would be right there. And 6, 4 would be right there. So we can graph our line. Okie doke. All right, now I know previously I said you only need 2 points to draw a line. Now, when you're using a table, it's helpful to get 3 or 4 points because you want to make sure that the points go in a line. If they don't go in a line, 2 things could happen. Either you made a mistake or the equation you're using is not a linear equation. We know how to determine if the equation is a linear equation or not, so we can do that and double check. And if it is a linear equation you're sure, then you want to double check your work. All right, here's one for you to try. Go ahead and pause the video and hit play when you're ready. Okay, we're back. So the first one, 2x minus y equals 2. So what I'm going to do is actually take this and solve it for y. I'm going to add y to both sides. Get 2x equals y plus 2, subtract 2, and you get 2x minus 2 equals y. All right, so since the number in front of x is not a fraction, doesn't really matter what I put in. So I'm going to put in, this is my x value, -1, 0, 1, and 2. When I put in -1, that's going to be 2 times -1 minus 2. So that's going to be -4, which gives me the point -1, -4. When I put in 0, I have 2 times 0 minus 2, which gives me -2. So it's 0, -2. When I put in 1, I would get 2 times 1 minus 2, which is 2 minus 2, which is 0. So I have 2 or 1, 0. And then when I put in 2, I'd have 2 times 2 minus 2, it's just 4 minus 2, which is 2. So it'd be the point 2, 2. So -1, -4 is here. 0, -2 is there. 1, 0, and 2, 2. They do go in a straight line, so right there. Okay, that's the graph of the linear equation. And you can see the intercept is 1, 0 here. And if I check the x-intercept, I put 0 in for y, I would have 2x equals 2, which you divide by 2 and you get x equals 1. Similarly, if you check the y-intercept, you would get y equals -2. Okay, so let's look at x equals 3. This sometimes messes people up. So x equals 3, that means that the x value is always 3. X is always 3. Doesn't matter. X is always 3. Doesn't matter what the y value is. So the y value can be anything. And remember what we said before. So if this is X and this is Y, then you can make the y value anything you want. -2, -1, 0, 1, 2, 3, so forth and so on. But remember what we said before. When you have X, it's just X equals a number, then it's a vertical line going through that x-intercept. So you would just go over here, put your vertical line. Similarly, when you have y equals a number, it's a horizontal line going through the y-intercept of that number. So I'm going to circle this in green so that we know it's green, the green line rather. So you have y equals -2, and bippity-bop, bippity-boop. Okay? All right, my mathematicians, that's it for this section. Please continue on to your assignment. As always, reach out to me if you have any questions. Make it a great day, and take care. See you later.